So hello everyone and welcome to lecture number 8. In the previous lecture we have seen two T junctions, that is one was H plane T, one was H plane T, H plane T junction, and the another was E plane T junction. Okay, we have seen this both of the junctions. Okay, H plane and E plane both. Now today, in today's lecture, what we are going to study is, we will study the combination of both of it. Means when we will combine both E and H plane, when we will combine both E and H plane, then what is going to happen? That plane, another plane, another T junction will be generated, that is EH, that is known as EH plane. We will study today EH plane. Okay, today we will study EH plane, or it is also known as hybrid or magic T junction. It is also known as hybrid or magic T junction. Okay, it is also known as hybrid or magic T junction. So today, in today's lecture, we are going to see the combination of E and H, that is gives rise to EH plane junction. That will give rise to EH plane junction. Okay, so first of all, in the same way as what we did for E plane and H plane, in the last lecture we will try to implement the S parameters, and we will find out the relation between A and B. We will find out the relation between A and B with respect to S scattering coefficient. We will find out the relation between A and B with respect to S scattering coefficient. As what we did, similarly we will did as what we did in the last lecture for E plane and H plane, similarly we will do for EH plane. Okay, so let us see first of all the structure. The structure is very important. Okay, the structure of E and H plane T. Okay, this is the structure of H plane T. This is the H arm. This is H arm. Okay, this is port 1. This is port 3. This one is port 2. Okay, this is H arm. This is H plane T junction. Now I will implement the E plane T junction on it. I will add E plane T junction on it. I will add E plane T junction, something like this. Sorry. Okay, I will add E plane T junction. Okay, this is E arm and port number 4. Okay, so this is EM and port number 4. In between, this will not become, this will not be there. Okay. So this is nothing but the E arm. This is connected to this. This will also be not visible. Okay. So this is the E arm connected to the H arm. Okay. We have already seen, and this is nothing but a combination of both of them. Okay. And what we are going to have is, we will have, this is the junction point. We will have this kind of thing. This is port 3. We will have input to it. This is H arm. This is H arm. This is port 2. This is port 4. This is port 1. Okay. This kind of the structure it will be having. This is E arm. This is just a signal structure. Don't consider it as a practical one. This is the practical one. This is the practical one which you are seeing over here. This is the practical structure of EH plane T junction or magic T junction. Let me write again. This is nothing but EH plane T or magic T or hybrid T. Okay, all these names are of the same, and we will keep this picture for our reference. To move ahead, we want to find out the relation between A and B. Okay. We will place this aside so that it can be visible to us, and we will start the derivations for S parameter. Okay, the first point will be the scattering matrix is a 4 cross 4 matrix. Okay, it's a 4 cross 4 matrix. So S will be given by S11, S12, S13, S14. Up till now we have just seen 3 cross 3 matrix. This is 4 cross 4 matrix. So S21, S22, S2 of 3, S2 of 4, S3 of 1, S3 of 2, S3 of 3, S3 of 4, and S4 of 1, S4 of 2, S4 of 3, S4 of 4. Okay, so this is nothing but the matrix. The second term is because H plane, because of H plane T junction, T section, H plane T section, that is this part, H plane T section, this part, H plane T section, we will have the properties of H plane T section over here, and that is given by S2 of 3. S2 of 3 will be equals to S1 of 3. Okay. Now moving ahead, we will have third property from E-plane T section. We will have S2 of 4 will be equals to minus of S1 of 4. Due to the E-plane T section, E-plane property, we will have S2 of 4 will be equals to minus of S1 of 4. Okay. Now number 4, because of the geometry, because of the geometry of input at input of port 3 cannot come out of port 4. Okay, since they are isolated. Remember this port 3 and port 4 are isolated ports. Port 3 and port 4 are isolated ports. Port 3 and port 4 are isolated ports. So as they are isolated ports, the input of port 3 cannot come out of port 4 since they are isolated ports. They are isolated ports. So S3 of 4 is equals to S4 of 3 will be equals to 0. Will be equals to 0. Okay. This will be equals to 0. Now number 5, that is from symmetric properties. From symmetric properties, that is Sij is equals to Sj of I, we will be having S1 of 2 is equals to S2 of 1 comma S1 of 3 is equals to S3 of 1 comma S2 of 3 is equals to S3 of 2 and S2 of 4 is equals to S4 of 2 comma S4 of 1 is equals to S1 of 4. Right? This is due to symmetric properties. Okay? Now, moving ahead to another point, another property of this E-plane T, that is number 6, port number 3 and 4 are perfectly matched. Port number 3 and port 4 are perfectly matched. Means they do not have any reflection. They do not have any reflection over here. Here also it will not have any reflection. Here also it will not have any reflection. Here also it will not have any kind of reflection. Okay? If it is not having any kind of reflection, then S3 of 3 is equals to S4 of 4 will be equals to 0. Now let us prepare the matrix using all those relations. The matrix which we will get will be in the form of S11, S12, S1 of 3, S1 of 4, S1 of 2, S2 of 2, S2 of 3, minus 1 into S1 of 4. Remember replacing it. S1 of 4, S1 of 3, S1 of 3, this is 0, 0, S1 of 4, minus of S1 of 4, this is also 0 and 0. Okay, so this is the scattering matrix which we have obtained after substituting all the relations which we have considered over here. Okay, now we know that from unitary property, we all know that number 7 or number 8, from unitary property, we have S into S star is equals to identity matrix, okay. This is known as identity matrix. This is I is nothing but identity matrix, okay. So we will write the whole term over here, that is S11, S12, S13, S14, S12, S22, S13 minus of S14, okay. S13, 0, 0, S1 of 4 minus S1 of 4, 0 and 0, okay. The same we will have with conjugate, that is star, and this will be equals to the identity matrix. The identity matrix is 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0 and 0, 0, 0, 1. Okay, this is identity matrix. This is S11 star, S12 star, S13 star, S14 star, okay, S12 star, S22 star, S13 star minus of S14 star, okay. Similarly, we will also have S13 star, this is S13, okay, this is 0, this is 0, this is also 0, that is also 0, okay, and S14 minus of S14 star, 0, 0, okay. Now using what we did, that is expanding all this, row 1 first column, right, R1 C1, that is row 1 first column, R1 C1, that is row 1 to first column, we will have S11 whole square plus S12 whole square plus S13 whole square plus S14 whole square is equals to 1. This is equation number 1. This is nothing but equation number 1. This is nothing but equation number 1. This is equation number 1. Okay. In the similar way, we will have R2 C2, that is row 2 column 2. We will have S12 whole square plus S22 whole square plus S13 whole square plus S14 whole square is equals to 1. This is equation number 2. This is equation number 2. Okay. This is equation number 2. Then you will have row 3 column 3. You will have S13 whole square plus S13 whole square is equals to 1. This will give us the S13 value is equals to 1 by root 2. Okay. This will be 2 S1 square. 2 will go in the denominator, and root will, and the square will go on the other side, forming the root for another one. Okay. Similarly for R4, C4, we will have S14 whole square plus S14 whole square is equals to 1, and we will have S14 value is equals to 1 by root 2. Okay, we will have S14 value equals to 1 by root 2. S13 is equals to 1 by root 2. Okay, this is due to row 4, column 4. Now equating equation number 1 and 2, because both the equations are having 1, so equating equation number 1 and 2, we will have S11 will be equals to S22. Okay, so substituting this in equation 1, we will have S11 whole square plus S12 whole square plus 1 by root 2 whole square plus 1 by root 2 whole square is equals to 1. Okay, now this will become S11 whole square plus S12 whole square plus 1 by 2 plus 1 by 2 is equals to 1, and S11 whole square plus S12 whole square is equals to this 1 by 2 and 1 will become 1, and minus 1 will be equals to 0, and this gives S11 is equals to S12. Okay, is equals to S12. As S11 is equals to 0, S11 is equals to 0, both are equals to 0, so S11 is equals to S12 will be equals to 0, and S22 will be equals to 0. As both the terms are equals to 0, we will have S22 equals to 0. Now, forming the scattering matrix, forming the total scattering matrix, we will get S is equals to 0, 0, 1 by root 2. This will have 1 by root 2. Then we know 0, 0. This is 1 by root 2. Minus of 1 by root 2. Then 1 by root 2. This is 1 by root 2. This is 0, 0. This is 1 by root 2. This is minus of 1 by root 2. This is 0 and this is 0. Now, to solve this, we will find out the relation between A and B. We know that B matrix is equals to S matrix into A matrix. Okay? Now B is nothing but the reflected or the output. A is nothing but the incident. S is nothing but the reflection coefficient. Okay? Moving ahead, we will find that B1, B2, B3, B4 is equals to 0, 0, 1 by root 2. This is 1 by root 2. This is 0, 0, 1 by root 2 minus 1 by root 2. And this is 1 by root 2. This is 1 by root 2. This is 0, 0, 1 by root 2. This is minus 1 by root 2. This is 0, 0. Okay? So this will be multiplied with A1, A2, A3, A4. Okay. Now again we will expand. Again we will expand this all with respect to first row, first columns in order to find out the relation between A and B. What we are going to get is B1 is equals to 1 by root 2 A3 plus A4. Right? Similarly, B2 is equals to 1 by root 2 into A3 minus A4. Similarly, we will have B3 and B4 is equals to 1 by root 2 into A1 plus A2. And B4 we will have 1 by root 2 into A1 minus A2. Now, taking this value of B1, B2, B3 and B4, A1, A2, A3 and A4, we will try to find out the values with different cases. We will try to find out for different cases. Okay? What we have done earlier. So, case 1. Case 1, where we are considering A3 is not equals to 0, comma A1 is equals to A2 is equals to A4 is equals to 0. We will get B1, this A1, A2, A3 and A4 values you have to substitute in the B1, B2, B3, B4 formula in order to get the B1 relation is A3 divided by root 2 comma B2 is equals to A3 divided by root 2 comma B3 is equals to B4 is equals to 0. Now this is the property of this is nothing but the property of H plane T. This is nothing but the property of H plane T. Okay, where we will get the output at B1 and B2. Okay, when A3 is input. Similarly, we will go for the second case. That is case 2. For case 2, we will have A4 is not equals to 0, comma A1 equals to A2 is equals to A3 is equals to 0. Then we will get B1 is equals to A4 by root 2, comma B2 is equals to minus A4 by root 2, comma B3 is equals to B4 is equals to 0. And this is the property of E-plane T junction. This is the property of E-plane T junction. This is the property of E-plane T junction. Okay. Now we will take case number 3. In case number 3, we will have A1 is not equals to 0, comma A2 is equals to A3 is equals to A4 is equals to 0. Then we will get B1 is equals to 0, comma B2 is equals to 0, comma B3 is equals to A1 by root 2, comma B4 is equals to A1 by root 2. Okay? When power is fed into port 1, nothing comes out of port 2. When power is fed at port 1, nothing comes out at port 2, right? Even though they are collinear ports. Even though they are collinear ports, okay? Even though they are collinear ports, and they are known as magic. That is why it is also known as magic T, and hence port 1 and 2 are called isolated ports. Port 1 and 2 are called isolated ports, and similarly an input at port 2 cannot come out at port 1. Similarly, input at port 2 cannot come out at port 1. Okay? So this is all about the case 3. Now let us take case 4. Let us take case 4, where A3 is equals to A4, comma A1 is equals to A2 is equals to 0. Okay? Then we will get B1 is equals to 1 by root 2 into A3, comma B2 is equals to 0, comma B3 is equals to B4 is equals to 0. This is nothing but the additive properties, right? This is nothing but additive properties. So if you give the input in port 4 and port 3, then you will get the output at port 1. But you will not get the output at port 2, port 3 and port 4. Port 3 ports are completely matched, so there will be no reflection, but port 2 you will not get anything. So this is nothing but the additive property. This is nothing but additive property. Equal input at port 3 and 4 results in an output at port 1, and that will in phase and equal in amplitude. So this is all about case 4. When you have input in port 3 and port 4, the output will come at port 1, but nothing is going to come at port 2. Okay? Now we'll see the last case, that is case number 5, and we will have A1 is equals to A2, comma A3 is equals to A4 is equals to 0. We are providing input to port 1 and port 2 and not providing input to port 3 and port 4. Okay? Then we will get B1 is equals to 0 is equals to B2 is equals to B4 and B3 is equals to 1 by root 2 of B1. Okay, we will not get the output at port 2 and port 4. We will not get the output at port 1 as we are providing same output, same input at port 1 and port 2. That is known as equal inputs at port 1 and 2 results in an output at port 3 results in an output at port 3, that is additive property, that is additive property, that is due to additive property and no output at port 1, 2 and 4, and no output at port 1, 2 and 4. So these are the 5 different cases for magic T junction or hybrid T junction or EH plane T junction which we have seen. Okay, so this is all about the EH plane T junction. Okay, thank you.